No, it's happening. Okay, good morning, everyone. I have the honor to introduce Mr. Sulayman Jawo to you, who is a seasonal NEA staff. That is a National Environment Agency, and his specialty is GIS, that is Geographic Information System. Sulayman is a master's degree holder in one of the top universities in Nigeria. He also studied information technology in the area of computer science at the Gambia Technical Training Institute, that is GTTI. Sulayman also did secured a networking certification, that is CCNA. And Sulayman has been working with the NEA since 2013, that is almost 12 years. And his areas of specialty, so the areas he has been concentrating at NEA is developing and maintaining national environment and spatial data. That is in relation to the GIS that he specializes in. He also produced GIS-based report and maps for policy support and planning. Among the things he also do is support national monitoring projects using satellite and UAV imagery. He collaborated on multi-agency initiatives related to land degradation, climate resilience, and biodiversity.
No software.
Sulayman have completed key projects and assignments that includes land degradation neutralization mapping. He also completed the National Forest Monitoring System that is in collaboration with FAO and RED, Coastal Ecosystem Assessment and Mapping Monitoring with NEA. He also participated in the Gambia Geolab platform contribution, which I think the consultant has an idea of. Sulayman also have skills in remote sensing, database and spatial data management. His specialties goes to dealing with tools like ARGS, QGIS, ANVI, SNAP. He also have skills in land use mapping, spatial analysis, visualization, and he can also do some programming, that is Python and JavaScript. So I think we will all learn from Sulayman, given his area of specialization and what we are trying to achieve here today. And Sulayman, I am honored to welcome you to go ahead with your project.
Thank you very much. And I'll be presenting on geospatial tools for mangrove monitoring in Gambia. Final project, which is done by myself. The first task was to show the mangrove extent of the entire country, which by looking at the map here, you'll see. And according to the statistics, the mangrove habitat in the Gambia covers like 60,000 hectares by 2020, which the coastline coverage in 2020 was 1,006 kilometers, and non-mangrove was 132 kilometers. Now, the second task was to show the net change in mangrove cover between 1996 and 2020. So looking at the map here and the statistics, here you can see we have gains and losses around this end, and also here. You can also see them around other places, but these two areas were the areas I selected because they are predominant in those areas. And those areas fall within Kaya Mansakonko area LRR, and here within the Tambi wetland. Significant positive net change in mangrove area, suggesting a large-scale mangrove gain between 1996 and 2009. There was also a sharp decline, moving into negative net change between 2010 and 16. Noticeable recovery within mangrove area regaining ground, which was in 2017 and 19. And there was a slight drop in net change compared to 2019, but still in positive territory. Now, the next one was the drivers of mangrove loss in the Gambia between 2020 and 2016. So according to the statistics, the major driver of mangrove loss in the country was caused by erosion, as you can see in the diagram. Now, looking at the mangrove alerts in the country, there were 189 mangrove disturbance alerts between 2020 and 2025. Okay? And looking at the map again, you can see alerts here. Okay? But I was very mindful because just by looking at this way, you might not be able to tell exactly where are the places that were seriously impacted. So what I did was, I had to zoom on these specific areas for you to see clearly. And those areas happens to be the Banjul dryport that falls within the Tambi wetland, and also the OMVG project around Yenda Bombatenda. Total carbon stock at national level. Gambia's mangroves are critical carbon reservoir with significant blue carbon potential, especially in soils. Conservation and careful management of these ecosystems can directly contribute to national and global climate goals. So you can see the importance mangrove has, especially that of the Gambia, the potentials that the total stock has. Now, I also took a look at the mangrove biomass and the mangrove height. Okay? The map on top represents the biomass, and the one under represents the mangrove height. Biomass density in Gambia was 54.05 tons per hectare in 2020, where regions like CRR, LRR, and NBR with high biomass mangrove heights, and these are ecologically important for blue carbon hotspots, biodiversity havens, enhanced coastal protection, water filtration, and nutrient cycling, etc. So on the map here, you can see the areas with good mangrove heights fall within LRR, NBR, and CRR. Okay? And the same goes for that of the biomass. The mean potential score for the Gambia is 70. This is an indicator of the likely ease for achieving successful restoration. Gambia's restorable mangrove areas represent just 1% of the total mangrove area. And areas not suitable has either been changed to commodities, example, agricultural use, aquaculture, and residence. Looking at the mangrove fisheries, there are wide variations in fishing pressure with some sites like Katong, Tanye, and we should not be surprised because you have fish landing sites here and another fish landing site here. So these are major fishing areas, okay? So in Gambia, the median mangrove fishing intensity is 376 days, ranging from 167 to 9,105. Now, mangrove alerts within the Tambi wetland, okay? Because for this exercise, I just took a specific area, Tambi wetland, which is actually a protected area. Yeah. So now, within the period of 2019 to November 2024, we had like 62 mangrove disturbance alerts, okay? And the area of mangrove habitat in this area is 44.55 kilometers square by 2020. Now, there were 62 mangrove disturbance alerts, as I mentioned earlier before, from February 2019 to November 2024, nearly 6 years of monitoring. The chart clearly shows a sharp spike around March 2021, indicating a significant number of alerts during the month, likely due to deforestation, degradation, or human activity. There are stretches with very few or no alerts between 2000 and mid-2023, suggesting relatively stable or undisturbed mangrove conditions. Now to the next topic, which is understanding the fundamentals of optical and radar remote sensing. Optical remote sensing is based on direction of solar radiation that interacts with the Earth's surface and is either reflected, absorbed, or transmitted by different materials. Ingredient sunlight energy from the sun reaches the Earth's surface in the form of electromagnetic radiation, primarily invisible. Reflection, a portion of this sunlight is reflected off the Earth's surface. Absorption, some of the sunlight is absorbed by the surface. So describe the classification workflow based on image provided. The first thing we do is to define our area of interest, load and process the imagery, calculate vegetation, load SRTM, and the list goes on, as you can see. What are the inputs and processing? Inputs are Landsat, age, vegetation, and water indices. Processing, filtering, cloud, and shadow masking. Now, describe the classification workflow on the image provided. So as you can see here, using Google Earth Engine, I have displayed the mangrove extent of these areas of interest, that is West Coast, LRR, NBR, Banjul, and Kanifing. Okay. Now you can also see the statistics here. The mangrove extent in square kilometer is 558, whereas the global mangrove world extension is 685. Though the figures are not equal, but we are close to it. Mangrove canopy height and biomass within the Tambi wetland. Okay, and there was a question with regards to why allometric equation. They are easily accessible, well documented, simple to apply. And how could using this global allometric equation, using it in the upcoming forest survey, how will it help the country? Driving local allometric equation, calibrating global